All right, so there is no 6.3, so we're skipping over that for 6.4. Again, keeping 2 lessons per week. Do kind of try to plan accordingly, because after chapter 6 is over, I think we'll be doing 3 lessons per week for 2 weeks in chapter 7. So again, just to make sure that you are aware of what's going on. But anyway, today's lesson has many parts. It's important that you take good notes on each part. At some point, the information you have will be put together with other information. In order to see it again, you have to focus on proper execution of each portion. So one thing we're talking about here is simplifying radicals. I think we've already covered how to do simplifying radicals. So let's just briefly review it. What we learned to do was to look for perfect numbers like 4, see if I can get my pen to work, 9, 25, and 49. And so what we did was we took 216 divided by 4 to see that we get the answer of 54. So it becomes 4 times 54. 4 doesn't go into 54, but 9 does. 54 is 9 times 6. And so what we learned to do one way was to look at 4, recognize that that is a perfect 2, because the square root of 4 is 2. That the square root of 9 is 3. And so we end up with 2 and 3 coming out. Again, the square root of 4 is 2. The square root of 9 is 3. So 2 and 3 both come out. And the last number, which we did not worry about, came out also. So you ended up with 6 root 6. That was how we did that part. Again, I forget what chapter it was, but I do know that we at least did it. So again, that's part of what we were looking at. The other thing is dealing with variables. Remember that this is division. It's the square root of x to the 9th, which means that you need 2 of them. So in this case, you have 9 x's, 4, 5, 6, 7, 8, 9, under a square root, and you're looking for sets of 2, because again, that is an invisible 2. So 1, 2, 3, 4 sets of 2 come out, and 1x had to stay on the inside. So again, that's kind of the 2 things that you need to be ready for. But again, just make sure that you're adjusting those to whatever else is in here, because again, it is going to get very interesting. So now we're going to be working with roots other than 2. Square root is the same as second root. As I said, there's an invisible 2 right there. But like I said, other root numbers will also work also. So third root of 648. One way to do that, third root of 648, is to just do the prime factorization. So what we're going to do is break 648 down into 2s, 3s, 5s, 7s, and 11s, and so on. So 648 divided by 2 is 324. Divided by 2 is 162. Again, 2's in there, which is 81. 81 is, well, I guess you could say 9 times 9, but we're going to keep breaking it down. 2 doesn't go into 81, but 3 does. 3 goes into 27. 3 goes into 9. And then there's another 3 there, so 2 more 3's. And if you check that out, 2 times 2 times 2 times 3 times 3 times 3 times 3, which was 3 2's, 3 2's and 4 3's. Notice how those prime numbers make 648. That's the prime factorization. It's like breaking a number down to its DNA. And what you're looking for whenever you do that the hard way, which again, at least just to get it done, is once you've broken it down to prime factorization, you're looking for groups of 3's. So here's 3 2's, that's going to come out. Here's 3 3's, it's going to come out. So again, a 2 comes out, a 3 comes out because there's 3 of those there, and that 3 has to stay in. So you end up with 6 times the third root of 3 would be what you would do. Now on paper, make sure you put that 3 inside the cup here. Don't put 6 to the third square root of 3, because that's something different. You want 6 root with a 3 in the V part, with the 3 right there. Same thing for 77, 76. Divided by 2 is 3888. Divided by another 2. So that's 2 2's, 3 2's, 4 2's, 5. So 5 of them. I think. So let me go back. 7776 divided by 1, 2, 3, 4, 5 2's. Again, the trick for 3 is the number should add up to something that's divisible by 3. 4 plus 2 is 6, plus 3 is 9, which means there's obviously a 3 in here. 1, 2, 3, 4, and 5. So 4 3s came out, and the 3 is left over, so 5 3s. And yes, I made these up, but it's just to make sure you understand. But in the fourth root, you're looking for groups of 4. So again, this is where things get interesting, because you have to make sure that you understand the rules of each type of root and how to break it down. And again, if you get lost, prime factorization is the safest way to do it. So that means that a 2 comes out because of that part, a 3 comes out because of that part, and 2 and 3 are both locked inside, which means you end up with 6 times the fourth root of 6 as your answer there. So again, that's the idea that we're looking at whenever we break down third roots, fourth roots numbers. And you pretty much did the same thing with 216, because 216 would have been 2 times 2 times 3. Actually, it would have been 3 2s. 2 times 2 times 2 times 3 times 3 times 3. Is that it? Because there's 2s and 4. It is. And there's your 216. So like I said, in breaking that down, we had 1 2 come out. We had 1 3 come out. There's your 6. We had 1 2 left over, 1 3 left over. There's your other 6. So the prime factorization works no matter what. But again, just kind of keep in mind. Again, but there are a couple ways to attack those problems. We just used prime factors and pulled out group, but we could use the perfect system that we used before. We would just have to figure out what the perfect numbers are. If you think about it, our numbers were 4, 9, 25, 49, also 121, and that was based on the main prime number. So example, 2 times 2, 4. 3 times 3, 9, 5 times 5, 25, 7 times 7, 49, and so on. But these are the first 5 prime numbers, and so if you wanted to create a perfect list for third root, you do 2 to the third, which is 8, 3 to the third, which is 27, 5 to the third, which is 125, and so on. It does help to memorize those numbers if you work with them a little bit, but again, those are your perfect third powers. You could do the same thing if you wanted to make a list of perfect fourth roots that you could divide out. So looking back here, you could have said, using the 4, 9, 25 thing, we could have taken the 648, using this number here. Let me get all this in the screen. The 648, we could have said, well, 8 is our first nice number, so we could have did 648 divided by 8 and broke it down to 8 times 81, and then 27 goes into 81, and so it would have been 648 would have been 8 times 81, which is 27 times 3. And so 8, again, was the perfect number of 2. 27 was a perfect number of 3. 2 times 3 is 6 with a 3 on the inside. And again, there's your 6 times the third root of 3. So that still works. You just got to make sure, again, you pick something that works for you and practice it. The only tricky part, again, is in the following situations where we have variables in there with different powers. And so what you have to do, again, you'll end up with w to the fourth. Again, pretty much with exponents, you got to divide, so it ends up being w to the second comes out. 5 divided by 2 is 2, remainder 1, so it'll be 2x's coming out. Y to the 6th divided by 2 would be y to the third. Z to the 7th coming out divided by 2 would be z to the third. And when you look at what's left over, since you divided by 2, nothing here. Since you divided by 2, there is 1x left over because you had 2, 4, 5. 6 or 3 groups of 6's came out. 7, 3 groups with 1 left on the inside. And what has to happen here is, because of negatives, and because first off, it's an even power, and because negatives exist with these numbers, if you put a negative value in here for w and it goes to an even power, there's no issue. If you have you can't have a negative here because a negative going to an odd power would be negative. So you can't do it with negatives, but our w to the fourth and w to the sixth are dangerous here because you could put a negative number here for w and it would still be positive. You could put a negative in here for y and it would still be positive because any negative number going to an even power comes out as positive, but a negative number going to an odd power comes out negative. So again, you can't have, since this is an even root and you can't have negatives, these have to be positive because there's no way that would come out positive if that x was negative. But this could be negative and that could be negative. Here's the thing, when you bring this out, w squared, if w was negative, w squared is fine, But y could be negative here, but if it was negative, that would make a negative number there, which means you actually have to put y to the third inside of absolute value. So again, kind of getting to the lesson of what we're talking about here, that's what you have to look out for whenever you go higher into your math. So again, even root, it was even on the inside. As long as it's even on the outside, it's okay. Even root, even on the inside, odd on the outside, needs that there. But again, odds you don't worry about because again, it's odd anyway, and you don't have to worry about it. So I have that written down for you here. So write those down and make sure you memorize this stuff. But again, all these conditions have to exist. First off, the root must be even. Second off, the inside exponent must be even. And then when you bring it out to the outside part, the outside exponent must be odd. So when you have an even root with an even exponent on the inside that results in an odd exponent on the outside, you have to put an absolute value around it. Again, also pay attention to instructions. If the instructions say something about assume all the variables are positive, then you don't need absolute values anyway. And a lot of those will do that. But I do have the absolute value stuff on your homework just to make sure you think about it. Because again, that's not something you want to be messing with or messing up on as you go higher. So let's look at a few examples from your homework. I won't be able to go over everything because there's no way to predict what types of problems you're going to face once you leave this class, but we should be okay. So 250, what I'm going to do here is I'm going to use the perfect third roots, again using 2, 3, 5, and 7. 2 to the third is 8, 3 to the third, 3 times 3 is 9, times 3 is 27, 5 to the third is 125, 7 to the third is 343. Again, memorize those because it makes these easier. So I will try 250 divided by 8 because 8's a perfect number under the third root system, not the square root, but the third root system. 8 is perfect. What about 250 divided by 27? Nope. What about 250 divided by 125? Yes, so it's 125, which again is one of my perfect numbers, times 2. 125 as a perfect number turns into a 5 because the third root of 125 is 5. So again, that's why it's the perfect number for that part. Since we make our list based off of those numbers 2, 3, 5, and 7, whatever number leads to it is the number that it breaks down to be. 2, of course, can't come out of itself, so again, it'll be 5 comes out, third root of 2, or you could have done the prime factorization with a bunch of 2s, 3s, 5s, and so on. So again, this was with perfect numbers. I think I already did a prime factorization for fourth, so again, I'm going to do perfect numbers for fourth just to show you that you can do that. 2, 3, 5, and 7, again being my main perfect numbers. Now I need to do 2 to the fourth. 2 times 2 is 4, times 2 is 8, times 2 is 16. That's 4 2s. 4 3s. 3 times 3 is 9, times 3 is 27, times 3 is 81. 5 times 5 is 25, 125 I think is 625, and notice how that's already bigger than 405, which means that that's already too big. So it's got to be 16s and 81s. I'm pretty sure 16 doesn't do it because 16 is an even number and it's not going to be 405. Nope. What about 81? Well, notice 81 goes in 5 times. So again, using perfect numbers, there's your 81. Again, 81 would break down to be a 3. And so you end up with 3 on the outside with 5 on the inside. So again, if you need to see the prime factor or the prime factorization mode, go back to the beginning of this part where I used a bunch of 2s and 3s and all that to figure out what it broke down to be. Where I ended up with like 2, 2, 2, 3, 3, 3. That's your prime factorization mode. Or you could use the perfect number mode. Any one of those works, but you have to get at least one of those in your system. Otherwise, you will not be able to survive this this section here. So when we go to everything, we've got to throw everything together, breaking down the number properly, and then breaking down all your variables while being careful about the rules. So first off, let's get the number 32 for the fourth power. 2, 3, I'll just go with 2 and 3 to start. 2 times 2 times 2 times 2, 2, 4, 8, 16. I'm pretty sure 16 goes into 32, so that'll be 16 times 2. So that means that that would break down to be a 2, 4th root of 2. And usually what I do for these is I kind of break everything down individually, and then I put it all back together. I'll show you what I mean. 32 breaks down to be that. X to the 8th would be just x squared, because remember we're doing 8 divided by 4, because you need sets of 4 to come out. So 8 would break down to 2 x's. Y would be, how many 4s go into 17? I think that's 4. With 1 left over. Again, 4 Y's would come out because 4 times 4 is 16. Plus another 1 makes 17. Again, 4 remainder 1, which is why the 1 stayed on the inside. And Z to the 13th is, you do 13 divided by 4, which is 3 remainder 1. So that means that 3 Z's come out, 1 stays in. And so putting all this together, 2 is out there, x squared's out there, y to the 4th is out there, and z to the 3rd is out there. So this, and this are all out. Don't forget that it's a 4th root. This number stays, no x's, 1 y, 1 z. And so again, organization is a crucial part of this, and just practicing it. Like I said, make sure you practice it to get it down, because if you don't, you are going to get confused. You will get left behind. And like I said, maybe you're using those alternate methods to get your homework done, but there's no way you can survive this as it gets tougher and tougher. So you need to at least practice this skill, because you're going to need it at some point. 2187 for the 3rd root. Actually, let's make sure of some things. Even power, even on the inside, odd. So we don't need anything for the x squared. Now, if that was like a 12 and that was a 3, then we would need absolute values. But remember, it needs to be, if you go back to your notes, even root, even on the inside, and odd on the outside. But since it's even, we don't have to worry about it. Since these two are odd, it doesn't come into play there. 2187 for those. Again, I'll go ahead and do the prime factorization thing. I'm pretty sure 2 doesn't go into 2187 because it would be even. So let's see. 1, 2, 3, 4, 5, 6, 7 3s. And again, using the prime factorization, I need groups of 3 of those. So there's 1, there's 2. So it'll be 3 and 3 comes out, which means 9 comes out. 1 3 stays in. Again, 3 times 3 came out as 9. That 3 had to stay with a 3rd root on the outside. For your 8, 3 goes into 8 twice with a remainder of 2. So it'll be x to the 2nd, because again, 3 goes in twice with a remainder of 2. 2 times 3 is 6, plus 2 makes 8. 3 goes into 14 4 times. So it'll be y to the 4th. That puts me up to 12 with a remainder of 2. And so putting all that together, these on the outside, 9 x squared y to the 4th times the 3rd root of 3 x squared y squared. Again, just make sure you take your time, and you want to make sure you get it down, because we're really going to be working with this stuff even more in tomorrow's lesson. And then the last one, 112 x 22 x to the 22nd y to the 19th. I don't like doing all the prime factorizations. I like the perfect numbers because it's easy enough to count by 2 and 3, plus I've memorized 2 and 3. 2 to the 4th is 2, 4, 8, 16. 3 to the 4th is 3, 9, 27, 81. So let's see, does 16 go into 112? It does, 7 times. So 16 times 7. Remember, 16 breaks down to be a 2. So this is 2 times the 4th root of 7. 4 and 22 goes in 5 times with 2 left over. 4 and 19 goes in 4 times with 3 left over. And I need to check my work, because you might even need absolute values for the inside if that's the case, but I'll check that out and get that back to you at some point, or just remind me in class and I'll be glad to look it up. But either way, we have our 2, our x to the 5th, and our y to the 4th. So 2x to the 5th, y to the 4th, 4th root of 7, x squared, y to the 3rd. Now go back to that check, because you want to do that. Even power, even on the inside, odd on the outside. Look at that. There it is. Even power, if you look at your notes, even power, or sorry, even root, even on the inside, odd on the outside means x to the 5th. Needs absolute values to make sure that we keep this the way it's supposed to be. So other than that, like I said, just make sure that you are practicing that stuff and trying to get it down. Again, asking questions and showing me the work you did, because there's no way I can explain this to you in an email like some of you like me to do. It's very hard to teach on email, but what it is easy to do is to say, hey, you messed up here, you need to make that number this, or that you might have multiplied wrong. Again, it's important you practice this skill. It is important in the upcoming section. In that section, we'll use rules learned to rationalize higher level problems. Please, again, be sure to email me with questions and be sure to include your work so I can assist you efficiently. Other than that, like I said, take care and good luck.